Good morning. We'd like to welcome you to Littlestown Foundry Incorporated. We're here in Littlestown, Pennsylvania. We'd like to give you a brief history of our company. Our company was founded in 1916 by Luther and Emery Snyder as an iron foundry, basically entertaining the hardware market. In the 20s, we got into the Vice line, which was very active for many years. We continued with the iron hardware until 1990 when we closed the iron foundry. We started the aluminum foundry in the early 40s, and today we are exclusively aluminum. The fact that we started in 1916 means that we are celebrating our 90th anniversary this year, and we're very proud of that fact. So let's go into the foundry and we'll show you what we're doing. We'd like to begin by explaining our core process. Any casting that has a hole in the inside of it has to have a core of a sort so that the interior remains hollow. What we do is we buy resin-coated sand, which is, the resin is a phenolic resin, which is a petroleum base. We would take an iron core box with this particular shape in it, and this is put on a machine and it's heated to about 450 degrees Fahrenheit. When the machine is at that temperature, sand is pneumatically invested or blown into the cavity. The other half is closed onto it, and then the exterior of the core bakes, and the interior of the core, the sand that isn't baked, runs back out, just like you would make a pie, or a pie crust, I should say. The interiors run out, consequently the term shell core. When we take that particular part and put it into the foundry, we'll see as we get over where this is being produced, where a mold is being made, the core is set into the mold, and then the metal is cast completely around the mold, allowed to solidify and shaken out. The core is broken out of the inside, leaving the hole in the casting as you see here. What we see here is a machine in operation. This is a completely automated machine where the sand has already been blown into the cavity. Right now it is what we're going through a curing process, or it's baking with that shell. Now it's opening. You'll see it automatically inject onto the belt. The cores will be removed and placed onto a conveyor for cooling. The cores are placed into a box for conveyance into the foundry where they would be placed into a particular mold. What we have set up here is an explanation of the casting process. We physically melt metal, and during the melting of the metal, we take certain assurances that the characteristics of the metal is exactly what we need it to be. Much of our work that we make goes to the electrical industry. So consequently, the material has to be extremely uniform, because when the part is used in the field, it may go on a high tension line where we would have an ice storm or a hurricane or a typhoon or any one of the other elements that take place. So that the casting has to be very uniform, and there has to have a certain amount of give to it. So that when we're making this part, this actually sets into the mold and makes this wedge shape that you see in the casting. The end result is a carrier that actually holds a conductor or a live wire onto a pole or onto a derrick. The conductor actually fits through the wedges that you see in here. Once it's put in place, there are no bolts involved on it. That clamps shut, and it serves the same purpose as like a Chinese handcuff. The harder you pull, the tighter it gets. That's the purpose of the clamping device. These are relatively new because they have replaced the bolting arrangement that you typically saw linemen clamping to a pole. I want to touch briefly on our maintenance department, which is to our right, and essentially we are very mechanized intensive, and that means that we have preventative programs set up for all our particular equipment. We know what equipment is being worked on, who is working on it, what parts were replaced, etc. And the reason for doing that, all right, is to establish a history on a particular piece of equipment and assure that we have the proper procedures in place so that our uptime or our production time is not interrupted. What we're doing here is we poured a sample of liquid metal into this stub, which is a core that we just saw. That sends a signal up to the processor and tells us what our metal quality is for a particular part that we're casting. Now we're going to go into the lab and we'll explain the significance of doing that.